Alright, so today we're going to be doing a video on two-dimensional kinematics. So we're going to have two particles. We're going to have particle A, and we're going to have particle B. So particle A is going to have, and this is on a two-dimensional Cartesian coordinate system, particle A is going to have an initial position. So initial position is going to be equal to negative 49 units in the y direction and 15 units in the x direction. And then for the initial position of particle B, it's going to be 21 units in the y direction and negative 37 units in the x direction. Now, we're going to find, we know the point at which they intersect, and so that's going to be 41 units in the y direction, and negative 13 units in the x direction. Now, we're going to have an initial velocity set for each, and so all that we're going to have to do is find the acceleration. So, the initial velocity is going to be, for B, it's going to be negative 6 meters per second squared in the x direction, and negative 2 meters per second squared in the y direction. And for A, it's going to be 5 meters per second squared in the x direction, and 1 meter per second squared in the y direction. So go ahead and write all of that down for this problem for now, and then we'll get on to the next part of it. Alright, so now that we have all of our variables established except for acceleration and final velocity, we are going to find, oh, and actually also time that it's going to take them to get there is going to be 6.3 seconds. It's another very important variable. So these are the kinematics equations. So we have final position equals initial position plus initial velocity times time plus 1/2 of acceleration times time squared. We also have the final velocity squared plus the initial velocity, equals the initial velocity squared plus 2 times the acceleration times time. Then we have final velocity equals initial velocity plus acceleration times time. Now, because we don't know initial velocity, but we know absolutely everything else, and we're trying to find acceleration, we're going to use this formula. So I'll go ahead and erase both of these, and then we're going to start plugging things in. So first, let's go ahead and do this for particle A. So we're going to have the final position, which you know for both, and that's going to be, we'll first do the y motion. So we have our little particle A, particle B, and then their intersection point. So, and then B. So, we're going to start with particle A, and we're going to track its motion in the y direction first. So, we know that the final position in the y direction is going to be 41. And then initial position for this is going to be negative 49, plus the initial velocity of 1 times 6.3, because that's time, plus 1/2 of A times 6.3 squared. So now we're going to start simplifying this. I'll just carry the 49 over, because I'm adding it to both sides, and then simplify this out, and we're going to have f of A, and then 6.3 squared is 39.69. So then we're going to subtract 6.3 from both sides, so we're going to get 83.7 equals 1/2 A times 39.69. So then we're going to multiply both sides by 2 and then divide by 39.69 to isolate A. So 83.7 times 2 divided by 39.69. So we're going to get that A, and it's going to have y hat, equals 4.217687075. So that's going to be the acceleration in the A direction for the first particle. Oh, wait up.